In this example, we are looking at two variables from a larger data set that's the sleep study data that we'll be using in some SPSS assignments in the course. The two variables we're looking at are the number of alcoholic drinks students reported having per week and the student's GPA for a sample of 253 students. If we look at the graph, first of all, we want to see what we have as a relationship between our number of alcoholic drinks and GPA. Notice that if we would think of drawing a line in here that we have a negative trend. As the number of alcoholic drinks per week increases, we're seeing a decrease in GPA. In addition to that, we do not have a very strong relationship here, so we would say that this is negative and weak. That is further validated by our correlation that we're given here of negative 0.2693 being a negative value and then close to 0, indicating that weak trend. When we're looking at the two variables, we need to think about which one would affect which, because the explanatory variable should have an impact on the response. Our explanatory variable here, which will impact the other variable, will be the number of drinks per week, because we would expect that to be affecting GPA and not the other way around. Then we are going to look at finding the best fitting line for this data. On the previous page, we had equation for slope, which says that you want to take your correlation, which here is negative 0.2693, and then multiply by the ratio of the S's. So in our table we're given, it's important that we identify what all these values are. Drinks was our X, our explanatory variable is always X, GPA is our Y, and we need to make sure those are in the right order because that will affect our line. So when we're looking at the averages, those are the same as means. This would be X bar and this would be Y bar. And when we're looking at the standard deviations, which we call S's, this would be S sub X and this would be S sub Y. So in this formula, we take S sub Y, which I'll just round to 0.404, and divide by S sub X, 4.095. This will give us a slope of negative 0.0266. Then to find our intercept B0, we take the mean of the Y's, our Y bar, which is 3.244, and we subtract our slope, so we'll have subtracting a negative 0.0266, so that will turn positive, times our mean of our x's, which is 5.569. This will give us an intercept of 3.392. So we write this as y hat, our fitted or predicted y value, will be the intercept, 3.392, plus our slope of negative 0.0266 times x. And if you want, you can get rid of the plus the negative slope and just write that as 3.392 minus 0.0266x.